Okay, so where we left off was, I think I just told you, I was kind of explaining to you how to explain to do the solubility test, right? I think that's where I left off. Right, so remember that your procedure needs to be very, very detailed. Okay, it has to include all the little nitty-gritty details, okay, that you would almost take for granted. Right, like when you're doing the solubility test, you know, you've already told them just to cover the bottom of the depression with the sample. Okay, to put the thermometer in the sample, record the temperature before. Add the water, okay, from the wash bottle, okay, fill it to about 2/3 to 3/4 full. These are all details that are, you know, cumbersome, but they need to be in there for the person to do it right, okay. And then to gently stir with the thermometer, okay, making sure to hold the thermometer by the little like rubber gripper, okay, so you're not interfering with the reading, okay. Stir. How long should I stir for? I would say probably a little more than 10 seconds, but give them a time frame, okay? The worst thing you can write down, and I've seen this, stir until dissolved. What if it's not soluble? They're going to stir forever, okay? Or until the water evaporates. But I mean, like, that's not going to work. You have to give them a time frame. If it's not soluble after 30 seconds, it's not going to dissolve, okay? You can give up then, right? It's not soluble, and you can write that. Okay, but the other thing that needs to be in there is, what are you looking for while you're stirring? While you're looking, here's some signs that something is soluble. A temperature change, okay, either up or, spoiler alert, down. You're going to have one that's going to get colder, okay, and also look for any changes in the color of the solution. Look for any changes in the shape of the material, especially if it's crystalline. If the crystals are shrinking, getting rounder, okay, or whatever, all of those are signs that the material is dissolved. Hopefully all of it will dissolve. We've got, you know, big enough sample size that we can do that, okay? But if it doesn't mean it wasn't soluble just because not all of it dissolved. If some of it dissolved, then it's somewhat soluble, okay? And that's what you need to record. Record all of those observations, okay? And tell the person in your procedure. These are all the observations to record. Okay, the test after solubility is what? Aqueous conductivity test. Okay, so do I need to make a new solution? Or can I keep the one from the previous step? Keep the one from the previous step. Probably not a bad idea to say that in your procedure. Using the solution created in step whatever, okay? Perform the conductivity test. Okay, how do I perform a conductivity test? Well, I make sure I've rinsed off the conductivity tester. Okay, I've tested it by pushing the button to see if the light comes on. Okay, all of that kind of stuff. Okay, there's all nitty-gritty details, but they need to be in there. Okay, place it in the solution, press the button. What am I recording?
What's the level?
Yeah, exactly. What's the level? Record the number on the face. Okay, is really what we're looking for there. Okay. Once that's done, what do you do with the tester? With distilled water, right? Okay. Wash or rinse it with distilled water. Okay. And then you're moving on to the pH test. Okay. pH test is fairly straightforward, right? You take the pH paper, dip it in the solution, and quickly compare it to the color chart. Record the number. Okay. That kind of stuff. Then for cleanup. Okay. Part of your procedure has to include the cleanup procedures. One of the most important parts of the cleanup procedure is that nothing goes down the sink. Okay? Some of these things contain heavy metals and acids and bases, and we don't want them to go down into the plumbing. Right? So they will go into the what I call the disgust bucket, okay, which is in the fume hood. Right now, it's not too disgusting because nothing's been put in it for months and months, and it was cleaned up hopefully. Okay. So it shouldn't be too bad, but if you do this second semester, it can be pretty gross. Okay, so what you'll do is you'll take your depression plate and your wash bottle, okay, you'll go into the fume hood, you'll dump the depression plate and then give it a quick rinse. If you drop it in the bucket, don't go after it, okay? I'll find a way to fish it out of there, but don't, your first reaction will be, and don't, okay? You'll come out with like bones, okay? Yeah, we don't want to do that, okay? If you drop it in, and I only say that because it's like happened twice, Okay, and not often at all, but it's happened, and people, your first reaction is, oh no, I dropped it, and you go reach for it. Don't try to pick it out of there. Okay, you have no idea what is in there. Okay, all right. So make sure you're talking about cleaning everything up, putting everything away, removing your safety goggles, all that kind of stuff. Okay, all of those are details that need to be in. Okay, are there any questions on what you're doing for the procedure? Okay. When we've done the lab, we have all of our observations recorded in that chart that's in your document. Okay, then you got to fill out this chart. This is your analysis. It's the only thing you're doing in the analysis. Okay, you'll tell me whether sample A was ionic or molecular, and how will you know that?
Just like the bios.
Okay, which property in particular tells me for sure? The conductivity test, right? Okay, if it conducts electricity, it's ionic. Okay. Boom, that's how you can tell that one, so that's an easy one. Okay, the compound identity, that's going to be a little bit trickier. Okay, in that one you're going to have to use all of those properties. Now, a couple of other little things for you here. Okay, this is a compound you're probably not all that familiar with. Ammonium nitrate. Okay, ammonium nitrate is the stuff, if you've ever used one of those instant cold packs, where you pop the little water bladder and then you shake it up. Okay, and you can hear the crystals inside. Okay, the crystals are ammonium nitrate. When they dissolve in water, they get cold. You might want to make a note of that because ammonium nitrate is one of your unknowns. Okay, and that's one of the ways you might be able to help yourself identify it during one of the tests you will run. Okay, during the lab. Okay, so ammonium nitrate does get colder. It's also an active ingredient in homemade explosives. What has to get locked up. Okay. I think that's the only one. The other ones are all fairly straightforward. Things also to watch for, okay? If I'm looking at this compound right here, hydrogen chloride, okay? Just knowing that it's an ionic compound and that it has hydrogen acting as a metal tells me that it's going to have what property? Any ionic compound where hydrogen is the metal is going to be an acid. Okay. Similarly, this is an ionic compound that ends in hydroxide. And any ionic compound that ends in hydroxide is going to be a base. This is what you're going to have to do when you're doing your analysis. Look at these compounds and say, okay, oh, that's a copper-containing compound, so it'll be blue. It'll be a blue crystalline solid that'll conduct electricity, blah, blah, blah. Okay, you kind of have to walk through what are the properties of each one of these things and then match them up to your observations. Okay, that's how you'll do the analysis. Okay, for the conclusion, right, copy and paste your hypothesis, and then based on what you were able to do here, okay, were you able to identify all the compounds? Did they have the patterns that you predicted? Did all, were there conductivities for ionic compounds? Talk about your data, okay, and how that can allow you to either accept or reject your hypothesis, okay? And then while you're doing the lab, think about anything that may be inconvenient, okay, or makes it difficult for you to do something. Those are your sources of error, okay? Think about some of those things while you're doing the lab. If they come up, just make a note of them, and then you can plug them in there when you're done, okay? Remember, you don't need to do the class discussion. Right? So obviously, we can't do the analysis or the conclusion or the evaluation today. Okay? But by Monday, you should have everything up to the procedure done. Okay? Written out and ready to go. And you're going to need that, okay, when you go over to the lab, because you're going to have to read the procedure off your phone. Okay? You're not going to take, we don't have any paper. Okay? We're not taking the Chromebooks over there. Okay? So you're going to have it ready to go on your phone so you can follow it from your phone, and that's probably where you'll do your observations as well. Okay, just fill in the chart in the Google Doc from your phone, unless you want to do a pen and paper and transfer later. All right, you have the rest of class to work on that. If you want to work together with some people, that's fine. Just mask up when you turn to talk to each other. All right, obviously in the lab on Monday, you'll be working in groups, which I'll let you pick, okay? And I'll make sure everybody gets in a group, okay, on that day. If you want to work on it by yourself, that's also fine. One thing you have to be aware of. Everybody's lab report needs to be unique, okay? You can't go, hey, you do the hypothesis and I'll do this part. No, okay? Everybody has to do their own thing. You can work on it together and they can be similar, that's fine, okay? But they can't be exact copies, or I did this and I copied yours and you did that and I copied yours. Okay, they can't go like that. Okay, any questions? Okay, get to work.